Okay, and you'll add them, and then time 1 and time 2 you'll add, you'll get total time. Clear? You can do it, guys? No? Didn't get it? You can ask me if in case you didn't get it. You didn't get it? You want me to repeat?
No, ma'am.
Okay, Jeba. Jeba, you want me to repeat? Jeba, am I audible? I think maybe she's facing network issue. Okay, so you will just put like this example 8.1 and the solution. Okay, quickly do the solution and tell me the answer. Done, Jasleen?
Yes, ma'am.
Okay, so let's just take the answer. So I hope you got the same answer. Is it 5.33?
Yes, ma'am.
And just remember one thing, you have to find average speed. That means your unit will be like SI unit will be meter per second, right?
Yes,
So
ma'am.
until and unless you are not writing meter per second, it is incomplete. Okay. Now the formula for average velocity, initial velocity plus final velocity. Okay, so initial velocity is represented by u and final is represented by v. Okay, so one question for this as well. Wait. You can see over here, what is the odometer of a car reads this kilometer at the start of a trip. Okay, so start means this is initial. Okay, and 2,400 kilometer at the end of the trip. Okay, if the trip took 8 hours, calculate the average speed of the car. So you have to calculate the average speed. Okay, so you know the formula of average speed.
Yes, ma'am.
Okay, so what you will write? Does it
Total
like
distance,
hmm hmm
speed, total distance by total time.
yes. So, but here just remember one thing, the odometer of a car reads 2000 kilometer at the start of the trip and 2400 kilometer at the end of the trip. Okay. So basically they are talking about like, the one thing which you have to mention over here is the total distance. But total distance, how you will be doing? You have any idea about it? Total this, how you will be doing it? No? Okay, just put it
Speed
and
into
just
time.
see what's the formula for average speed?
Distance
Total
by time.
distance. Total distance upon time.
Total
Okay.
time.
So over here you have time. Okay, total time you have.
Yes.
Okay, but you are getting one thing over here. They are telling you about the initial as well as the final. Okay, so that means you have to first of all do few things where you will be finding the average velocity.
Okay,
Okay,
ma'am.
so that means because your distance is given, like they are not saying that for the first hour you travel this, they are telling that it was 200, right, and 2000, and then it became 2400. So basically if you subtract it, what you are getting 200. So this is your S. Okay, the total
Okay, ma'am.
distance and divided by this. Okay, so once you get this, then you will be finding out, like they just converted it, so you don't need to convert, just find it out like this. Okay.
Okay, ma'am.
Done.
Yes, ma'am.
Okay. Now the next question. Oh, so sorry. Now see, the question is, Usha swings in in a 90-meter long pool. She covers 180 meter in 1 minute by swimming from one end to another and back along the same straight path. Find the average speed and average velocity of Usha. Okay. So you know what is the formula of average speed first of all, right? So Usha swims in a 90-meter long pool. She covers 180 meter in 1 minute, okay, by swimming from one end to another and back along the edge. So how much she's covering? 180 she's covering in 1 minute. So that means she's covering total 180. And what is the total time she's taking?
1 minute.
Yes. So you will just find it out. Okay. So you will get the answer for the average speed. But when you have to find average velocity, so what will be the velocity? Tell me. Average velocity, what is the formula? Displacement upon.
Displacement by time.
So what is the displacement? She covers 180 meter in 1 minute by swimming from one end to another. So matlab she just went there and she came back. So what is the displacement right now?
0.
Yes, 0. And you already know what the time taken, right? So time taken is basically 1 minute, right?
Yes,
So
ma'am.
1 meter, okay, so you can find it out easily. Then I'll tell you the conversion, how you're going to convert. Okay, because here you can say it is in meter, but this is in minute. So you can convert it. You, instead of writing 1 minute, what you can write? 1 minute equals to how many seconds?
60 seconds.
Yes. So instead of writing 1 minute, what you can write? You can write 60 seconds. Okay. So that you will get the answer in meter per second because meter already given.
Okay, ma'am.
Done.
Yes, ma'am.
So basically, this is what, instead of writing, 1 minute, they have just, you can write 60 seconds, you will get the same answer, right? Is it? No?
Yes, ma'am.
Yes, ma'am.
And the average velocity is very simple, 0, because your displacement is 0 and 60. So it is, if you will divide it, so you'll get 0. So your average velocity is 0 meter per second, but your average speed is 3 meter per second. Okay. Now the next thing which we are going to do, change in velocity, which is known as acceleration. So acceleration is very important. So you have two formulas. One is change in velocity upon time taken. So change in velocity is basically v minus u upon t. This is initial velocity minus, right? Clear? Yes, no, girls. You have written the formula now. You have that formula. Just check
Yes,
your
ma'am.
formula. Yes. So change in velocity is initial and final velocity you are going to do. And then you are going to solve it like this only. Okay, you just have to put. So you can see u to the final velocity and v. Okay, so u is initial and the final velocity will be marked. Oh no, this is your initial, this is your final. Clear? Yes, no.
Yes.
Yes, ma'am.
Okay. So remember, for example, I told you I was riding a bicycle. So of course, when I was starting a bicycle, then what was my initial speed at that time, or the velocity? It was 0. And then I stopped my bicycle at this rate. So whenever you are starting an object, right? So that is somewhere, initially its speed or velocity will be 0. And for example, I started my bicycle, then this is your home. I came here, then I started. So the first case will be when my initial will be 0 and whatever my speed will be, you will be calculating. But in second phase, my initial will be like what was my final at that time, that will be my initial. And then other the new final. Okay. So you can see, starting from a stationary position, Rahul pedals his bicycle to attain the velocity of 6 meter in 30 seconds. So basically this is your time t1, right? Clear? T1. But you can see this is a velocity. So ma'am, what is this velocity? So what I told you over here, the question is starting from a stationary position. Stationary position means fixed position. So at that moment, what will be the initial? What will be the initial velocity? Tell me, or the speed? If this is an object, what
0.
is the? Yes. Why? Because this is fixed, na? He is not moving. So initial will be 0 and inertial velocity will be 0, and then he attained the velocity of this. This will be the final one. Clear? So this will be the case number 1. And then he applies brakes such that the velocity of the bicycle comes down to 4 meter per second in the next 5 seconds. So first case is this, from where he started and he came here. Then he applies brake, then the second phase started. Okay. So in the second phase, this will become your initial, right? And this will be your final, right? And this will be your time, T2. Clear?
Yes, ma'am.
Okay. So you have to find the acceleration. So you'll find acceleration for case 1, where you will be taking initial one 0 and the final one this, and time will be this. Okay. And then you will be finding acceleration in second case. Clear? In both the cases you have to find. I hope you got the meaning of the question.
Yes.
Okay, both the girls.
Yes, ma'am.
Okay, so quickly do it. Case 1, case 2. You know the formula of acceleration, right? Change in velocity. So change in velocity is basically you have to use this formula. Okay, v minus u upon t. So you have v, you have u, you have t. Just put the formula and get the answer. Put the value and get the answer. Done, guys?
Done, ma'am.
Yes.
Of you? Oh. So I hope you got the answer. This is 6 minus 0. So you got the answer 6 divided by 3, which is 0.2. Yes. And this same 0. This. But remember, this is minus 0.5, right? Because this is 4 minus 6. So if you will subtract 4, you cannot subtract 4 out of 6. So your answer will be minus, right? Clear? And then if you will solve it, get the answer 2, 5. So it's like 0, so 0.4. Clear? Any problem in solving this? 2 upon 5? You want me to explain it?
Yes, ma'am.
Guys? Okay. Because I can understand this calculation sometimes because it's easy to subtract. Sorry, it's easy to divide few things, but it's become complicated. Over here you can see it's 4 minus 6. So what you got? You got 2 divided by 5, which is minus 2. Okay. So it's like your denominator is more than your numerator. So how you are going to do it? Of course, this is going to be 5 here, and this is going to 2 here. Of course, you cannot divide this, right? Because in 5 table, if you count 5 table, you cannot get 2. So over here, what we do? We put 0. Okay, and over here also we put 0 and point. Okay, and then you can simply divide. You can get 20 in 5 table. Yes. 5 into 5. 5 multiplied by 2 is 10. 5 multiplied by 3 is 15. 5 multiplied by 4 is 20. So you got the answer. Clear? So whenever you get a question like this, for example, you are getting 7 and 3. Okay. So again, you cannot solve it. So first of all, you'll put 0 over here. You will put 0 and point. Okay. And then you'll just 7. You'll just count 7 tables. 7 and 7 century 14, 7 century 28. So 4 you got over here. It is 28. So you got a 2 reminder. Then again you can put 0. And then again you can put 2, then again 14, like this you will carry on. Okay, if you get 2 digits, so the answer is 0.40. Clear?
Yes.
Okay. I hope you people don't get confused from next time that how to solve it when your numerator is more than your denominator, when your numerator is less than denominator. Okay, so simply need to put 0, and over here you need to put 0 and point. That's it. Okay. Now the next question. So you have 3 formulas over here. Just quickly revise these 3 formulas and then we'll do questions based on this. Done? Girls, done?
Just a second.
Okay, no problem.
Done, ma'am.
Both of you done?
Yes, ma'am.
Now this question. A train starting from rest attain a velocity of 72 km per hour in 5 minutes. Okay. So you are assuming that your acceleration is uniform. So first of all, you have to find the acceleration. You can find it out? Yes. I think you can find it out. You know the formula of acceleration? Yes. Yes. No. You know the formula of acceleration, right? The normal formula which we were using. Change in velocity divided by t, time. So you know the change in velocity. Over here, what is the initial velocity and final velocity? Tell me. Initial velocity is? Tell me. It's written over here. The train is in rest.
0.
So what? Yes. 0. And what will be the final? This one. You have,
72 kilometers.
yes. And time is already given. So you can find out the acceleration. Yes. Yes. No.
Yes, ma'am.
Okay. So quickly find it out. First one. Then I'll discuss the second one. Done, guys? Got the answer?
Yes, ma'am.
Okay. Now the second one is you have to find the distance. That means you have to find the S. Okay. So now what you have? First of all, just write what you have. You have V, you have U, you have A. Right? You have these two things and the T as well. Right? You have these four things with you. You know the value of these four things? Yes.
Yes.
And what you have to find? You have to find S. Okay, because distance means S. So you have three formulas with you, right? Over here. So which one you think? See, of course, the first one you cannot use because here you cannot find out, right? And here you can find out this, right? Plus you can use this formula as well, right? You can use this formula as well to find out S. So this one is easy because here you have half and all that. This one is easy. You can use this formula and you can get the answer. Clear?
Yes.
Okay. So you can find it out. Just put it in formula and get the answer. Okay. So you can do it like this as well. S equals to V square minus U square divided by 2A. Right? This will be easier, right? Got it? You have to find S. So you can do V square minus U square divided by 2A because this 2A is in multiply. So it will come here down. Okay. And just put the formula. You have V, you have U, you have 2, you have A as well. You find out you, right? Just put the value and you'll get the answer.
Done, ma'am.
Okay, both of you done?
Yes, sir.
So basically, I hope you got the answer like this only, 3 kilometer, right?
Yes, ma'am.
Now the next example, this is your homework, the same thing. The car accelerated uniformly from 18 kilometer to 36. So basically, this is your initial, right? And this is your final. And this is your time. So you have to first find acceleration, then you have to find distance. So again, you have to find this distance. So you can use any formula from where you can find out s. You can do this? Yes? The
Yes,
same
ma'am.
formula. Oh, good. I think both of you can do this, right? It is same like 8.5. Okay? Yes, guys?
Yes, ma'am.
Yes, sir.
Now, next 8.7. The brakes applied to a car produce an acceleration of 6 meter per second in opposite direction to the motion. If the car takes 2 seconds to stop after the applications of brake, calculate the distance. Okay, so here you can see what is your A. Acceleration is given, right? T is also given. So now you will be asking them what is our final initial and the final velocity, right? So it is going to be 0, right? Because you applied brakes. So that means it comes to 0, the final one. Yes,
Yes, ma'am.
right? So you have A, you have T, you have this. So you can find out distance, right? So over here you'll find out like which formula will be suitable for this. So I think this one you cannot find it out because you don't have this, right? But others you can find out this you can use, right? Yes. See here, you can use this formula and you'll get the answer. Clear? No, not clear. Guys, not clear. See, you have this formula, okay? B plus U plus AT, right? So from here, what you will find, you don't have this, right? So you have the final one, na? So you will get the initial one from here, right? You'll just put it in formula and you'll get the answer, right? And then you can use any formula where S you can from where you can calculate S and you'll get the S. You can use this formula or other formula or any other formula. Clear? So, but in case you know wherever the word brake is coming, you have to remember that your final velocity is going to be 0. Okay. So from this, because you have this, you have A, you have T. You can find out the initial one. Yes. And once you find out initial one, you can put it. You have three formula to find. You have two formula to find out S. You can put any. You can use any formula and you will get the S. Clear? No. Just leave. I think Jeva some network issue. You got it.
Yes, ma'am.
Then uniform one. That's it. These were the examples which we covered. So you will be revising all the things. And next class we'll be doing NCRT and then we'll be done with this chapter. I hope you are getting the idea for the numericals, how you are going to solve it. They are not that much, you can say hilarious one. But yeah, of course, you need to remember the formulas and you need to remember where you are going to apply which formula. If you know the formula, I guess 50% of the problem is solved, right? If you know the formula, right? And then 20% you have to work which formula to choose the formula. And once you are done with this, 70% of the work is done. Rest 30 depends on your calculation, how you are calculating, right?